Learning how to build and implement CNNs is a crucial skill if you're aiming for roles such as a deep learning engineer, AI engineer, or machine learning developer. Welcome to today's video where we will be diving into convolutional neural networks or CNNs and how we can use them to classify images. Now, if you're new to the concept of CNNs, don't worry, let's start with the basics. Imagine that you have got an image, like a picture of a cat, dog, or car. Now, the goal of a CNN is to teach a computer how to recognize these images, just like how we humans recognize objects. It does this by using layers, kind of like how we break down tasks into smaller steps. And if you haven't seen our previous video where we talk about CNNs in more detail, be sure to check it out first, it's right over here. It will help you understand the basics before we dive into the implementation. And in this video, we will walk you through how CNNs work and how to set one up. We'll be using a dataset called CIFAR-10. It's a collection of 60,000 images of 10 different things like airplanes, cars, and cats that we can teach our computer to recognize. We'll also talk about something called max pooling, which is a simple trick that helps the computer work faster and more accurately by making the images smaller and easier to process. And by the end of this video, you'll know exactly how to build your own CNN to classify images just like the experts. And let me tell you, this video is a part of our AI/ML track job-oriented program, which has already helped professionals like Utkarsh, Shrija, Debashish, and Roshan land exciting new jobs in AI. Want to know how? Stick around to find out how you can start your own career transformation with our free 90-minute masterclass on AI/ML and Agentic AI. You can register through the link right there in the description and pinned comment. So now let's jump in and get started.
So this is like the CIFAR data set, okay, and in that we are having multiple images, okay, around 60,000 images we are having, which belong to the 10 classes, okay, and for each class we are having 6,000 images, okay. Now 50,000 images are considered for the training and 10,000 images are considered for the testing, okay. Since this is the already available data set, so we'll be using this split only, okay. Now in this, what we are going to do, we are going to create this convolution layer, okay, this kind of convolution layer. So we will be having the convolution layer 1, convolution layer 2. After that we'll perform the max pooling operation, then again convolution layer, and then we'll be performing the max pooling operation, then we'll having the third convolution layer, okay. After that, what we do, we will be having this flatten layer, then we will be having the fully connected layer like this, okay. Now there are total, you can say, the 10 classes that are present in the CIFAR dataset. So the classes over here will be the airplane, automobile, bird, cat, deer, dog, frog, horse, sheep, and the truck, okay. So these are the multiple classes that are present over here, okay. Now these classes that belong to this CIFAR dataset are colored image, okay, colored image. That means they are having three channels, okay, three channels. Now this three channel image having the size like 32 by 32 by 3, okay. So here 3 is for the color channel, okay. Now 32 by 32, okay. So the size of that particular image is 32 by 32, and because of this RGB we are having the three channels over there, okay. So we'll load that data first, and we'll do some pre-processing, simple pre-processing, because this is already clean data set, okay. We don't need to worry about the pre-processing part. So for that, what I have done over here, so I have imported this TensorFlow module. After that, input layer, dense layer, convolution 2D layer, max pooling 2D layer, and we don't doing the regularization, okay. So the flatten layer. Then for the data to import, we are having this CIFAR, okay, CIFAR, and we are using only that one, okay. Now in order to do the random selection of the images, we are just using this random seed, okay, random seed, and for that we are using the seed value 42, Okay, so it will be like randomly selecting and making our data or training deterministic, so that there will be no random selection for the next iteration. Okay, so we are just doing this random seed. Now here the name of the class is airplane, automobile, bird. So I have taken from here only. Okay, so just to put all those values like this. Okay, now after that we will be loading the data CIFAR-10 load data, and we put that into the X train, Y train, X test and Y test. So while loading only, it will like split the data into X train, Y train, X test and Y test. Okay, so it will take time. Okay, so I have done some experimentation before coming to the session, so it is not showing me the time over there. Okay, so it will take more time depending upon your internet speed. Okay, so while it will download the data, and it will store the data in the cache memory. Okay, for the particular, you can say, the session. Once the session is aborted, then all the data will be vanished from the machine. Okay, now here you can see 50,000 images are in the training, 32 by 32 by 3. Okay, so 32 by 32 and the 3 is the channel size. Okay, and in the X test we are having the 10,000 images. Okay, so when I plot those images, so 32 by 32 images, so here you can see these are the colored images, like this is the frog, this is a truck, right? Something is there, then the car is there, right? Horse is there. Okay, and then sparrow, bird is there, right? So these are the classes that are considered: airplane, automobile, bird, cat, deer, dog, frog, horse, sheep, and truck. So these are the 10 classes. And there are total, you can say, the 60,000 images as explained. And each class is having 6,000 images. Okay. Now, after that, what we can do here, we are just pre-processing our data. Okay. Pre-processing our data and converting the pixel size between the 0 and the 1. Okay, so what we are just going to do here, so we are just reducing the size of the image as well. Float 32 we are considering, and then dividing that by 255. So all the images will be shrink between the 0 to 1. Okay, and the size will be smaller. Okay, now when I see the label over here for the first image, so it is the 6. Okay, so the index is 6. So the for the 6 index, it is frog. It is frog. So therefore this one is the frog image over here. Okay, so I just verified by just extracting the single image. Okay, if you extract the second image, okay, if you extract the second image, then you will be getting the another size. Okay, so I'm not executing this, because just I'll execute this once again. So there you can see this is the 9. Okay, so this one is the truck. Okay, so here you can see the last one is the truck. So in this way all these images are placed. Okay, now here we will be creating this kind of structure. Okay, this kind of structure. Now how to create this structure there? So I am calling this sequential model. Okay, then first I will add the simple input. Okay, it is just used to give the what is the standard size of my, you can say, the input. Okay, so it is the 32 by 32 by 3. Okay, this is the size of the image. After that, here I am adding the convolution block 1. Okay, so this is the convolution block 1. So model dot add convolution 2D. Here I'm mentioning that filter will be 32 by 32. Okay, filters are total 32, sorry, and the kernel size is 3 by 3. Okay, padding is same, and activation function is relu. Okay, again here I am adding another layer of convolution. Okay, there also I am having activation relu. Okay, after that I am adding this max pooling, and there I am having the size of that pooling window as 2 by 2, so that this 32 by 32 will be reduced to 16 by 16. Okay, 16 by 16. Now after that I am having another same block, okay, convolution layer 2. So there you can see I have just copied from here and paste it over here. Okay, paste it over here. I haven't done anything, right? So here I am using 64 filters, okay, and the max pooling size as 2 by 2. Then again I just copied it and paste it over here, okay, and here as well I'm using this the kernel 3 by 3, then the filter 64, and the max pooling here, okay. So up till here I have added the convolution layer, okay. So this is similar to this one, okay. So this convolution layer 1, 2, 3, 4, I have added all those things, okay. So I have considered only 3 there. Now, after the final layer that I have considered for the feature extraction, what I'll do, I will flatten my, you can say, the final layer, okay? And after that, I will feed that into the dense neural network, okay? So this is the simple, you can say, the neural network, okay? So there, what I have done, I have added the flatten layer. So what it will do, whatever may be the output that I am getting after this, so that will be converted into a single flatten layer. Then I have added a single dense layer there, okay. And after that, the final output layer where we are having 10 number of neurons because there are total 10 classes in which we need to classify all those images, and for that we are having this softmax activation function, okay. So in this way this simple, you can say, the model is created, okay. So here I have added the input layer, then the convolution block 1, convolution block 2, convolution block 3, and after that the flattened layer is added, then the single hidden layer and the output layer, okay. So in this way the structure of my the convolution neural network is created. Now from this I have seen that there are total like 66 6 lakh 69,000 354 trainable parameters, okay. So in this entire neural network, okay, for this smaller image I am having how many, there are total, you can say, is 6,69,354 images, okay. So in this way we for the single you can say the images, this kind of, you can say, the parameters will be considered, okay. Now suppose I just do the experiment there, okay. I just copied it, and here what I can do here, the model, in the model I just change it, okay. So we'll see what will happen if we are having the larger image, okay. So this is the model 2, suppose, and if I am having the size of the image like 4K image there, so this is the size that I will considering, okay, 3840 by 2160 there, okay, and this is the color image, right? So suppose if I create this architecture and if I just see the summary for that particular model underscore 2, so we don't use the raw images, okay, because of there are lot of trainable parameters that we need to consider while training our model. You got it? Now after creating this you can say the convolution block there, so I will just delete it so that it will not affect my training there in future, okay. Now what I will do, I will compile my you can say the model, okay. So there I'm using a Adam optimizer, then for the multi-class classification, sparse categorical cross entropy, and then matrix that I am using is accuracy, okay. Now here I'm doing the training on my model. So extend train. Here I'm using batch size to 56 so that the training will become fast. Okay. 10 epochs I'm running for the experiment purpose. And there I'm also using the validation in between. Okay. So that it is comparing all the validation loss as well. and the training loss. Okay, so here I'm using the 30% as a validation. Okay, so here when I perform this execution, okay, so there you can see I'll be like able to achieve the accuracy for the training as 81% and for the validation 71%. Okay, so it is overfitting. Okay, so we don't need to worry about it, because after overfitting we have seen that there are so many, you can say, the regularization steps that we need to follow, right? Now when I see the training loss and the validation loss, okay, so both are decreasing and the accuracy is increasing in that case. Okay, now here I will be doing the prediction. Okay, so what it will do here, it will calculate the probabilities because of the softmax activation function. Okay, so for all those you can say the classes, it will give me the probability value. Okay, so here in my case the probability of the cat or the class 3 is highest. Okay, that's why my classifier will classify that that particular image is the cat image. Okay, so when I do this prediction, so model dot predict, here I'll be passing x test, and when I do the prediction, so it is giving the probability values of all the classes, right? So when I do this np.argmax on the first image, so it is giving me the third index. When I use that, okay, for my third index, so it is a cat. Okay, it is a cat because as you can see here in my list there, on the third index we are having cat, right? So I have just extracted that label from there only. Okay, from there only. So so that will be the cat image. Okay, so in this way you can perform this classification task. Okay.
And that's a wrap. We have walked through the full implementation of a convolutional neural network using the CIFAR-10 dataset, from setting up the convolution layers to optimizing and evaluating your model. So whether you're aiming for a role as a deep learning engineer, AI engineer, or machine learning developer, CNNs are a must-know tool for image classification tasks in real-world applications. And if you're ready to level up your AI skills, join our free 90-minute masterclass on AI, machine learning, GenAI, and Agentic AI. Register now through the link in the description and pinned comments. So thanks for watching, and if you like this video, make sure that you watch this video next.